Okay. So intersecting graph is not new to us. It's simultaneous equation. Okay, when two graphs intersect, you solve the equation simultaneously. Do we remember that? Okay, so before we begin, can I ask you to attempt question 1A? Okay, no, 1D. 1A, A is usually a simple question. 1D. Let's everybody quickly do question 1D. This one, maybe I enlarge it. This one. So the question is to find the coordinate of point of intersection of the two graphs. Please take note of the question so I can open something else. So how many of you got something and you think, oh, no, this is not normal? Raise your hand. You got something and you feel it's not normal. Exactly. That's because you're all doing the right thing. Okay. There are three possible scenarios you can have when we have questions like that. Okay. Put it down. I saw your hand now. Is Vena frozen or she's just trying to salute? Okay. Because your camera was this for more than 10 seconds. So I thought you joined the military and you're trying to salute the whole class. All right. So it's possible, like I said, to have what you have. Okay. I knew question D will be a bit different. You know, A is always the easy question. When you go deeper and deeper into the problems, then you start seeing different scenarios. All right. So there are three possible scenarios, and that I'm going to explain quickly. Okay. Let's come to the board. I was writing something while you were doing this. Now, if you have quadratic and linear function, of course, the quadratic gives either this or this. Okay, I need everyone's attention. The linear is always a straight line, either this, or even this. Okay, usually we wouldn't be talking about this one. Okay, we can talk about this one. This is graph of y equals a. This is graph of x is equal to b. Then both this and this are graphs of ax plus b. Okay, if a is positive, this is what you have. If a is negative, this is what you have. And these are the graphs of y equals ax squared plus bx plus c. Okay, so whatever we discuss now is generalization. It works for every possible case that we might have. So I'm going to just look at the minimum one, okay, and the straight line maybe like this. Okay, so you have one scenario is they intersect in two places. I'm going to draw this properly well, so just listen. Another scenario is you have this, and another scenario is you have that. If it's the case of maximum, you can have something like this, or it could be something like that, intersect in two ways. If it intersects in one place, you can have this, or you can have that intersecting in one place. If it doesn't intersect, you can have this, or if it doesn't intersect, you can have that. Does that make sense? So these are the possible cases. Of course, this we can also have in this form. This we can also have in this form and also in this form. Okay, so these are all the possible cases you can have depending on which type of line you are dealing with. So we're just going to deal with this and this and this. So let's get rid of the rest of them to avoid confusion. I'm still writing this properly for you. If they intersect in two places, that is when you get two coordinates. Which means you all know when you're solving, just like you did, you would have equated the two equations, isn't it? Then you formed a quadratic equation. Talk to me, please. Yeah? Can I just try to see if you understand? Okay. So I need your response. Either you nod or you say something. Okay. So if you have that, if you have the quadratic equation and it leads to two different values of x, then you know you are bound to get two equations, two coordinates. It means this is the format. It means it intersects in two places. In some cases, you might end up getting a quadratic equation like this. Maybe x squared minus 4x plus 4 is equal to 0. Okay, after you equate the two of them, you get the quadratic equation like this. This will only give you one value, 2. Because the equations here are equal roots. Does that make sense? So you get x is equal to 2 or x is equal, please do not write what I'm writing here. Just pay attention. Whatever I will write under this, I'm going to write it after this explanation, please. So if you solve this kind of equation, after you merge maybe y equals whatever and y equals ax plus b, okay, and you end up with this type of equation, you get 2. Now if you substitute 2 into this linear, you get only 1y. Which means it doesn't make sense to say 2, 3 and 2, 3. It's actually the same point. In that case, you are dealing with this type of situation. It means they only meet at one point. Now, the case you have just solved, whereby your quadratic does not have a solution, it means there is no point of intersection. So this is the case I gave you in the question. You are not wrong. It's just one of the 3 scenarios. One scenario is to have 2 values of x after you solve the quadratic, which means the line and the curve meet at 2 points. One scenario is to have just 1 value of x after you solve the quadratic, which means the line and the curve meet at only 1 point. The last scenario is to have a quadratic equation that does not have a real root. It means they do not intersect on the xy plane. So, but on the complex plane, of course, you might have a solution. Are you with me? But remember, when we are dealing with this, remember the video on complex number we showed? So there is another imaginary plane where you could have a solution. But we are not dealing with that. We are only dealing with the xy axis. So on the Cartesian coordinate, you do not have a solution, which means on the Cartesian coordinate, they do not meet. Am I making sense? Okay, so those are the 3 scenarios. Now, one other thing I would like to mention, if you have a curve and a line and it touches at only 1 point, we say this line is a tangent to the curve. This principle we also use in calculus when trying to find the gradient of a curve at a particular point. Okay, even in quadratic graph, you must have done this. In quadratic graph, if the question is, this is your quadratic graph, and the question is find the gradient of this graph at x is equal to 2. Then we were taught to draw a tangent to the curve to meet the curve at x is equal to 2. Remember this? Then you draw a triangle, okay? This triangle to help you find the gradient of this red line. Am I making sense? Because the gradient of this tangent to this curve at this point is the gradient of this curve at that point. So this line that touches at 1 point is what I'm talking about now. That line is called a tangent to the curve. A tangent only touches at 1 point, please. A tangent only touches at 1 point. Can I ask you to please look online on Google now and check seconds? Seconds. I'm not talking about sec theta, okay? Seconds, we can talk about seconds in trigonometry, and that is the inverse of cos. I'm talking about seconds in terms of geometry as a line, seconds as a line. What do you see? Has anyone seen anything? Seconds as a line. You can put the word as a line too to narrow down your search. Seconds as a line. What does it mean? Mara Brandy, have you seen something?
I'm not sure if it's correct though, but I think it just means it's a straight line that crosses 2 point on a curved line, something like that.
You're correct. That's it. My point is, you see the first scenario here? This line is not a tangent, but a secant. Okay? Why this line is a tangent? So the word tangent and secant, the words tangent and secant can be, we talk about them in two different areas of math, in trig and in geometry. Okay? In trig, maybe I write that properly. In trigonometry, hold on. Maybe let's write this first, so I don't mix them up. I don't mess up your notes. Let's write this first. So there are three scenarios when a graph, when a curve and a line meet. There are three scenarios. So let's write that details, so you have something to go over later. A section of graphs. Okay. When a quadratic graph y equals ax squared plus bx plus c intersects with the line y equals mx plus n, or should I say ax plus, I don't want to use ax plus b again. So let's just say mx plus n. There are three possible, okay, there are three possible scenarios. I hope I got that spelling right. So the first scenario looks like this. So the second scenario is like that. Okay. Let's see. So we're going to call them case 1, case 2, case 3. Or scenario 1, scenario 2, scenario 3. So we have three possible cases. Case one. The equation, the quadratic equation actually formed. Maybe I start with the same preamble. Sorry, please. Okay. When y equals ax squared and plus bx plus c, and y equals mx plus n are equated, a quadratic equation, I said the quadratic equation, yeah, that's better. The quadratic equation formed gives two distinct roots. Distinct roots in case one. This means the line and the curve, there are 2 points of intersection. Let's put it that way. So in the second case, it gives equal roots. Case two. This means there is only one point of intersection. Okay. There's only one point of intersection. And in the third case, it gives complex roots. In case three. This means there is no point of intersection. So that's what this means. Case one, the straight line before then, you should say that the above also is also applicable to two curves. What I mean by two curves is one curve and another curve. Does that make sense, guys? Do you get what I mean? So all this that we have written, everything here, Okay, it's not just a line and a curve. It could be a quadratic curve and a cubic graph. The same thing. It could be a quadratic and another quadratic. One maximum, one minimum. It could be one quadratic minimum, another quadratic minimum, and they meet. You can see they meet somewhere here. Who knows? Maybe they still meet somewhere. We don't know. Okay, so it works for, it's applicable for any two graphs. Okay, the above, let's write that first before we start talking about the line. So the above is also applicable if two curves intersect. If we have two curves, sorry, if we have two curves, my bad. Because what if they do not intersect? If we have two curves. So, which means if you have a situation like this, and the other is like that, you see they never intersect, right? Look at this. They never intersect, okay? Can you see what I'm saying? They never intersect, so that's like this third case. So it means when you equate them, you end up getting a no solution problem. Okay, so it's not just about line and curve, it is also applicable if we have two curves. Okay, if we have two curves. So I put in brackets, if we have two curves, not just a line and a curve. Because our picture only shows line and curve. So it's not just a line and a curve. It's applicable if we have two curves. Can I move to the next slide? Okay. All right, I'll move to the next one now. So I'll take this off since clear. So now let's talk about tangent and secant. Tangents, a tangent is a straight line or maybe I put in brackets geometry, because in trigonometry the two means different things. The tangent is a straight line which touches the curve at only one point. So I would say as seen in case one, not as seen in case two. Okay. I hope everybody understand what I mean by that. So this is the tangent, okay? So we say that line is a tangent to the curve, okay? So the pink line is a tangent to the curve. A secant, on the other hand, is a straight line which touches curve at 2 points as seen in case 1. In case 3 is just a line. It's not a tangent, it's not a secant. Note, in trig, tangents and secants are ratios of sides of right angle triangle. So y tangents is the ratio of opposites over adjacents. I believe you know this. Secant is inverse of cos. And that would be, because cos is A over H, this would be hypotenuse over adjacent. Okay, so when we talk about secant and tangent, if somebody asks you, what do you understand by secant or tangent? The first question you should ask is, in trig or in geometry? So if the person now says in both, then you have to explain it differently. Okay, it's like a language that means, it's like a word that means different things in 2 different languages. Okay, we're talking about trig, it means something else. We're talking about geometry, it means something else. That cat is paying so much attention, even more than most of you. Do you see that? The cat is paying so much attention. We need to tell SON that we might have a potential student in the cat. All right, so please take note of that. So one question I would want us to do is this. I will be sending it to the Edmodo group. We all know how to do intersection, so we're not going to waste too much time on that. What is it? Oh, the question you are trying to do, did you try to plot it on Desmos to see? Let's plot it together. Don't worry, let's plot it together. Everyone, so I'm going to share my screen with you now. Can you see my graphing calculator online? Are you seeing Desmos or the textbook? Talk to me, please.
Desmos.
Okay. Thank you, Miss Karen. All right, so y equals, the first one is negative x squared. Can someone give me the equation so I don't have to go between windows? The equation, Karen, you want to help?
Y equals negative x squared plus 4x minus 7.
Minus 7, and the other equation is?
Y equals 5x minus 4.
Can you see this, everyone? Guys, can you see this? This is why you are getting that complex root, because as this curve extends indefinitely, even this line keeps running away from it. Can you see that? The line keeps running away for whatever. The curve must be mean. That's why the line is running away. Anyways, so can you see they do not touch. So that is case 3 that we are talking about. So this is why you are getting a complex root. So once you get to that point, just say there are no solution, there are no point of intersection. Once you try to solve it, so what would you advise is the best thing to do if I just want you to check if there are point of intersection or not? Can anybody guess what you can do to just tell us without finding a point of intersection, just to tell us if there are point of intersection or not? Krista C, you want to try? I give you a curve and a line. Okay, are you with me, Krista?
Yes.
Okay, so I give you a curve and a line. I'm not interested in their point of intersection. I want you to tell me which scenario, which case it belongs to. Is it 1 point? Is it 2 points of intersection? Or is it no point of intersection? What would you do? But I don't want to see the intersection point.
Just plug in decimals.
No, without technology now. That's very smart of you. Without technology, what would you do? Anyone? Ethan, you want to say something? Say that again.
Like each other. You make the two graphs equal each other, and then you see the kind of equation it would give when it equals 0.
Okay, so you equate the two together, then you see the kind of equation. So how do I know? By looking at the equation.
Oh, if you get like two like x plus a times x plus b, then it's gonna be case 1. If it's just one,
I think that's kind of too long because I'm not interested in what they are. So you doing that, you're actually doing more than necessary. You have a point, but that's way too, we're trying to avoid doing unnecessary. But you're right. You equate them, you get the equation. So my point is, from that point, how do I know the number of intersection without solving further? I don't want to put it in completing the square. I don't want to factorize. I just want to know if there are points of intersection or not. Anyone, please?
We use the discriminant.
Just use discriminant. That's another application of discriminant. Does that make sense to everyone?
Yep.
So once you equate the two together, get your quadratic equation, find the discriminant, and that tells you if there are intersection or not. Remember the notes that I wrote on the board. Let's go to the notes. Look at this. This says when this and this are equated, a quadratic equation is formed. Okay, the quadratic equation form gives two distinct roots in case 1, which means you need to check the nature of roots. Does that make sense now? Check the nature of roots after you merge them and you form a quadratic equation. Just check the nature of the roots. Okay? So, I don't know if checking the nature of the equation of roots will be the first thing to do. That might be it, so as not to all try to solve it. Once you start looking for the factors and you can't get a factor, then maybe it's in decimal form, or maybe it doesn't even have a solution. If you have simple equation like x squared minus 5x plus 6, you can always get a factor, right? And that's proceed normally, get the values of x. If you do not have, do you get what I'm saying, everybody? Wave your hand if you understand what I mean. Okay, so if you get simple equation that you can get the factor easily, get the factor, and you know that's good. If you do not have a simple equation that you cannot get a factor easily, just use the quadratic formula. While using your quadratic formula, your nature of your discriminants, observe it under the square root. Are you with me? Observe the discriminant under the square root. Once under the square root gives something negative, conclude. Don't use 2i, 3i. We're not interested in your knowledge of complex number. Okay, once you see negative, maybe 2 plus or minus square root of minus 4 divided by 7. Just conclude the two graphs. Since the roots are complex, the two graphs cannot intersect, or the line and the curve cannot intersect. Just conclude straight away. The reason I want you to use the discriminant, the reason I want you to use the quadratic formula is you might have formed an equation whose roots are decimals. You get my point? Remember, there are two distinct roots if the discriminant is greater than 0. We never said if the discriminant is a perfect square. So your number under the square root may not be 9, 25, 16. It could be 13, which will end up giving you 3 point something. Am I making sense? And 3 point something with the after the plus or minus enables you to find two distinct roots, even though you have to approximate maybe to 2 decimal places or 3 decimal places. You know, we also have that on the graph as well. So if you do not have a monic equation like x squared plus 5x plus 6, that you can easily see the factors. You are having 2x squared, maybe plus 7x minus 9 equals to 0. Don't waste time trying to think of what the factors are. Of course, if you are very smart with figuring out the factors, go for it. But do not waste your time. State your quadratic formula, slot in A, B, and C, and wait until you get to that last part. So once under the square root you get a positive number, you are good to go. It means you have two intersection points. Find the intersection point if the question asks you to find it. If the question doesn't ask you to find it, once you get something like square root of 5 under the second part of your quadratic formula, you get what I mean? Once you get to that point, conclude there are 2 points of intersection, because we're only interested in how many intersections. Okay? In fact, if the question is to find the number of intersections, you don't even need to get to that point, I think. Once you form the equation, use discriminant and state the number of intersections. That's it. Do you understand? But if we are interested in number of intersection, slot it in. Once you get to that point and you notice there are 2, work it out. If you notice you have a complex number, just state immediately there are no intersection. If you notice there are equal roots, the equal root may also be in form of a fraction. Equation 4x squared plus 4x plus 1 will give you 2 equal roots, half each. Okay? So please, let's take note of these things. We have very little time to go. So I believe you can always figure this out on your own. So we're not going to waste too much time on finding point of intersection in the class. Okay? Rather, I'll go to this question in the book. I'll give you a few minutes quickly to solve it. Can you see the textbook? All right, so here are some nice, very sweet questions. Sweet, very, very, very sweet. So look at this. You see, I'm going to ask you to do question 4, okay? Question 4 says, consider, then we'll do the correction and that will be all. You know, that will be all. Did I say we're going to extend today's class by 30 minutes or that was just Monday? That was Monday. Okay, so we better try to round up before it's too late. Okay, so question 4. I guess we can't do the word problem yet. We would do the word problem by me just assigning a few questions to you as word problem without doing it in the class. When you come back on Friday, you show me whatever you have done. Okay, so quickly do question 4. You see this plot part, you can use decimals or you can use your scientific calculator. Okay, I'll show you how to use, how to get the last part from that, but you give it a try at first, quickly. Question 4, everybody get to work. I'll stop you in the next 3 minutes, whether you complete it or not. So we can spend maybe extra 5 minutes for the correction. Can I ask everybody to stop? Let's do the correction together, because something is smelling nice here, so I need to investigate, if you understand what I mean. I need to investigate what's going on in that kitchen. You know what I mean by investigate, right? Krista understand me. You see, Krista C is saying yes. Investigate, Mr. Daniel. I support you on this. Clarissa, you agree with me, right? There's need for investigation. You know, this aroma is obstructing my lesson, so there is need for investigation. All right. So I believe Nakita won't be happy if my line is too messy. She taught me to be OCD. The question says, consider y equals, so give me the two equations, anybody, quickly. Y equals what?
X squared plus
plus
x
2x.
minus 3.
X squared plus?
2x minus 3.
And the other one?
Y equals to x minus 1.
Okay. So what you did was to equate. After equating, then we get, this is a monic equation. We can see the factors easily, 2 and 1. So that will be plus 2 and minus 1. So either x plus 2 is equal to 0, or x minus 1 is equal to 0. So x is equal to negative 2, or x is equal to 1. So those are the two values of x that make this equation that. So put x into the linear. Please don't use the quadratic, you're just wasting your time. So from the first one, y will be equal to negative 2, negative 1. From the other part, y will be 1 minus 1. So here, y is minus 3, and here, y is equal to 0. So therefore, the point of intersection are minus 2, minus 3, and 1, 0. Okay, the points of intersection. Okay, so there are 2 points of intersection. What is the next question? The next question says, plot the graph on the same axis. Okay, let's do that. Plot the graph on the same axis. Nakita, give me the equation again, please.
X squared plus 2x minus 3.
3, and the other is?
X minus 1.
All right, so, and we can see, can everybody see my decimals page? Can you see my decimals page? Okay, good. So we can see this is one answer that we got, 1, 0. This is the other answer that we got, right? So the last question will now be used from here. Where is it again? Okay, this is my screen. The last question says, hence solve x squared. Can you see? It says find the range of values. That's what it means. For which this quadratic is above. Everybody, please, do you understand? This quadratic is above the linear. That's what it means. Look at it. The quadratic here, the quadratic is below the linear. Can you see? But here, the quadratic is above the linear. From this point, backward. and from this point forward. Am I making sense? From here forward, the quadratic is above the linear. Also, from this point backward, the quadratic is above the linear. But within this range, the linear is above the quadratic. Okay? Talk to me, please. You understood? Okay, so let's come to the board and wrap up that. So first of all, let's have a sketch like we have it on the Desmos app. So B, part of the question, we have this. And there is a straight line. Okay, so we have that. So these points, we've calculated that to be -2, -3. Why did I leave this? Okay. Oh, okay. This is -2, -3. Can you see that? And this point is 0, what? 1, 0. Okay, so there are two ways. So we want to solve the equation, the inequality, x squared, where is that question again? X squared minus 2x, is it -3? Plus 2x minus 3, okay, thanks. Plus 2x, thanks Leon, plus greater than x minus 1. So this is the curve, this is the line. This means above it, because this is a y value. So all y values of the curve greater than all y values of the line. And remember, your y-axis is this, right? So when we are talking about all y values, we're talking about values from here to here. Okay? So this is the point from here backward is where these are all the y values of the curve from this point. Do you agree? And these are all the y values for the line from this point. Okay? Do you understand that? And this equation is actually the y value. Everything combined is the y value. Everything combined is the y value. Does that make sense now? So that's why I said what this inequality is actually talking about is look at the sketch and tell us the range of values for which the line the curve is above the line. That's it. And remember, for these 2 points, the intersection is not included because in that point they are equal. Okay? They are equal. So basically, the solution will be, can anybody guess?
Smaller than -2.
So from the sketch, just a minute. The solution is, yes, Lillian?
X smaller than -2 and x greater than 1.
Okay, or actually, because or means we are combining the possibility and sound like intersection. Does that make sense? So it's not greater than or equal to. You can select any value, x greater than 1, let's say 4, right? Talk to me, please. Yes? Let's substitute. On the left-hand side, you have 16 plus 8 minus 3. Will it be greater than 3? Hello? Will it be greater than 3? Aha. Now let's pick a value within this Please, this point, let's pick a value here. That is a value between -2 and 1. Pick a value, Brandon.
-1.
-1. So let's substitute -1 here. You get +1, -2, -3. Let's see if it is greater than -1, -1. So this is negative what? 4. Is it greater than -2? Is -4 greater than -2? No, which is obvious. You can see that. When you pick that, this curve is not greater than this straight line. So that is what this inequality means. That's what it wants you to do. All right. Another way to write this, can somebody think, finally, another way of writing this inequality is what? You could also say, this is C, the answer for C. So we could also say what? The real number except set of x in this range do you agree? That's another way to say it. Remember, we use this notation during which topic? Under what topic did we use this notation? What did we learn when we use this notation? Karen?
Range and domain.
Range and domain, very good. Range and domain. So when we learned range and domain, we use this notation, right? So you can say everything in R except this set. And that is the same as this. Does this make sense, please? Okay, so I'll send you the picture. So this is the A part of the question. We took this question from page 377, question 4, just for the record, so you can remember later. Problem on page 377. Is that the core textbook? Okay, so that's exercise 14E. If there are no questions, I'd like to end the class, and I'll be seeing you on Friday. Okay, I'll send the screenshot of the page. I'll tell you which question to do, and I will add some word problems. We have not done word problem, but I believe you can always think about it. I'm happy to screenshot an example of word problem in the textbook so that you can do self-study on your own, solve some of the problems that I will ask you to do, practice the rest on your own, but compulsorily do the ones I will ask you to do, all right? And if you have any question, we'll solve more word problem on Friday, then we'll look at what is next, okay? Any questions from anyone? All right, I'll see you all on Friday.